All right, the converse of the Pythagorean theorem. So remember, the Pythagorean theorem said if you have a right triangle, then the legs a squared plus b squared are equal to the hypotenuse squared. The converse, remember, means to reverse the order. So now we're saying that if the sum of the squares of the legs is equal to the square of that third and longest side, okay, so what you want to make sure of here is that you have the two short sides here and that this is the longest. Okay, so the rule is that if the two legs squared and added together equals the third side squared, then you have a right triangle. So it's going the opposite order. Instead of saying it's a right triangle so we can use this property, we're going the other way. If this property applies, then you must be working with a right triangle. With that, we get numbers that are called, or sets of numbers that are called Pythagorean triples. So that comes across when we are trying to check to see if specific numbers form a right triangle, lengths of sides. One very important thing is to be a Pythagorean triple, it has to do two things. One, they have to be whole numbers. Okay, so if you have three whole numbers, and they have to satisfy the Pythagorean theorem, meaning when you square the two smaller ones and add them together, they're equal to the largest one squared. Okay, so, but it has to be a whole number to be, they all have to be whole numbers for it to be a Pythagorean triple. Okay, so here we go. Determine whether each set of side lengths would form a right triangle or not. We're just going to check here. Okay, so when you're checking, what you want to do is find the two shortest or smallest ones, so in this case 6 and 8, square them, and check to see if they're equal to that largest one squared. So this is a question mark right now. Okay, 6 squared is 36, 8 squared is 64, and 10 squared is 100. You're asking yourself, is 36 plus 64 equal to 100? And it is. 100 does equal 100. So 6, 8, and 10, yes, they would form a right triangle, and they would be a Pythagorean triple because they're all whole numbers. Let's try this one, okay? The two shorter ones, 4 and 7, do they equal 11 squared? So 4 squared plus 7 squared equal 11 squared. 4 squared is 16, 7 squared is 49, and 11 squared is 121. 16 plus 49 is 65, which is definitely not 121. So no, this would not be a right triangle. In fact, this one isn't a triangle at all. Remember, we had properties for sides of triangles, and in order to be a triangle, the two sides added together had to be greater than the third side. And 4 plus 7 is 11. It's not greater than 11. So this is actually not even a triangle at all, let alone not a right triangle. All right, so it says use a calculator to find the missing side length. Then tell whether the side length forms a Pythagorean triple. So here we go. We're back with our Pythagorean theorem. Okay, we're going to find the missing side, and then we're going to say if we have a Pythagorean triple or not. So we start, so here I have this x value. The Pythagorean theorem is a squared plus b squared equals c squared. My legs are x and 12, so I have x squared plus 12 squared equals 14 squared. Okay, square those. 12 squared is 144, 14 squared is 196. I would subtract 144 from both sides. And I get 52. I then have to take the square root of both sides. Okay, and it says use a calculator, so I don't have to leave this in radical form. I can just round it off. I get about 7.2. Okay, so I found the third side. The other thing I'm supposed to answer is, would these be a Pythagorean triple? Would 12 Would 7.2, 12, and 14 be a Pythagorean triple? No, not a Pythagorean triple because they have to be whole numbers, and this 7.2 is not a whole number. They do form a right triangle, but they're not a Pythagorean triple because they were not whole numbers. All right, here's another one. So we're going to use a calculator again to find the length of the missing side. Again, we start with the Pythagorean theorem. A squared plus b squared equals c squared, which we can use on any right triangle. One of our legs is x, the other is 10, and our hypotenuse is 26. That gives me x squared plus 100 equals 676. Want to solve that for x, so we subtract 100 from both sides. We have x squared is 576. To remove the squared, we would do the square root of both sides. And that gives me that x is 24. So my missing side here has a length of 24. The next question is, so here's my missing side. The next question is, would these three side lengths form a Pythagorean triple? Would 24, 10, and 26? Yes, they're sides of a right triangle and they are all whole numbers. So yes, they would be a Pythagorean triple.